this is your extra review, possibly for pre-calc 11 classes. So here we go. State the vertex. This is already in vertex form. That is P, that is Q. Since it says negative P, the vertex must be negative 2, vertex X, which equals 2, and the vertex Y is 3, 2, negative 3. Graph this and label the vertex. Again, it is in vertex form, so negative 4, but look, I've made it very tricky. Each square is worth 2, so negative 4, negative 2 is right there. Then I'm going up by 9, so I go over 1, and I got to go up 9, 2, 4, 6, 8, 9, right in the middle of that one, and then 1 away, right there. It is long and skinny, and that's the vertex at negative 4, negative 2. Now, this question I'm going to work over here because I need room to work. Tennis ball follows that path where H is the height of the ball above the court, D is the distance the ball goes from the tennis player. So let's visualize that. We're not drawing the graph, we're just going to visualize it. The tennis player hits the ball and it goes up a little and this way. Here is D, here is H. Now, since the tennis player is hitting the ball and he's not lying on the ground, that is how high above court level did the tennis player hit the ball. That is what I see. That is the y-intercept. Every single y-intercept is 0, y. So y equals negative 1 over 144, x minus 12 squared plus 2. X is 0. So y equals negative 144 times negative 12, 0 minus 12 squared plus 2. Negative 1 over 144 times 144 plus 2. Cancel, cancel. Y equals negative 1 plus 2. Y equals 1. That is 1 meter above the ground. Architect is modeling this window. I want the standard form, and I want the domain and range. So, first thing I need is standard form. Now I look at this and I see, oh, I've got roots. Once I have roots, I know y equals a, x plus 5, x minus 5. Y equals a, x squared minus 25. Now I'm almost in standard form. Now I have to find my x's and y's, so I got to choose a point. So 1, looks okay. I'm at 25, I think, and 24. So it looks like over 1, down 1. But I can't be sure of that 25, can I? So I'm going to keep sliding until I find another point. That one looks good. 3 and 16. So I'm going to go 16 equals a. 3 squared minus 25. 16 equals a. 9 minus 25. 16 equals negative 16a. A equals negative 1. And that's what we thought up here anyway. So y equals negative a times x squared minus 25. Get rid of those brackets because I want standard form, negative x squared plus 25. Then I want the domain and range. Well, my domain is negative 5 less than or equal to x less than or equal to 5, and my range y is less than or equal to 25. If I'm doing this, now Jacob in block D made a suggestion that this is what the real window would look like, but of course the real domain is x is a set of real numbers and y is less than or equal to 25, because of course that will stretch out. The water is spraying from that fountain, so h equals negative 2/3 d squared plus 4d. I want to graph it. So right now, it's not particularly useful to me because that's standard form. But I do know that my y-intercept is 0, so I've got 1 point there. Because this has nothing written there. Now, what I'm going to do with that is factor that. So h equals d negative 2/3 d plus 4. Now, since h is 0, I know that one is d has to equal 0, which we know. But the other one, negative 2/3 d plus 4 has to equal 0. So negative 2/3 d has to equal negative 4. Multiply by 3, negative 2d has to equal negative 12. Because I multiplied both sides by 3 to get rid of the denominator. And then d equals 6. So my next root is d equals 6, which means I have my two roots, so my vertex is right in the middle. Vertex x equals 6 plus 0 divided by 2, which equals 3. So there's my vertex x equals 3. Now what do I do with 3? I put it back in here. H equals negative 2/3 times 3 squared plus 4 times 3, which is negative 2/3 times 9 plus 12. Negative 2/3 times 9 is negative 6 plus 12. H equals 6. So that is my Vy. And that is what it looks like. What horizontal distance does the water travel for the fountain jet to reach its maximum height? 3 meters. Maximum height, 6 meters. And lastly, this question. I'm throwing the ball off a bridge. The bridge, this is what it's going to look like. This is time. I lie. Yep, time. This is height. So at 0 time, 0, 0, 35. The bridge is right there. That's where I'm starting from. That's what it's going to look like. There's my maximum. So I need my vertex. My vertex, my Vx, equals the time to get there. My Vy equals the height. So let's find that vertex. Vx equals negative b over 2a, which is negative 10 over 2 times negative 5, which is negative 10 over negative 10, which is 1. So my Vx is 1. That's the time to get there. How long does it take the ball to get there? 1 second. Now I need the height. Height, I'll change colors. Height equals negative 5 times 1 squared plus 10 times 1 plus 35. Negative 5 plus 10 plus 35 equals 40. 40 meters is the height above the water. When does the ball hit the water? That's right here. That's a root. So I have to use my roots. T equals, what finds roots of a yucky thing like that? The quadratic formula. Negative 10 plus or minus the root of 100 minus 4 times negative 5 times 35 over negative 10, which is negative 10 plus or minus the root of 800 over negative 10. Now, since I want a real-life answer, I can go ahead and I can just punch that into my calculator. If I wanted an exact answer, I would have to simplify that. If I was going to simplify it, that is 400 times 2. So that is plus or minus 20 root 2 over negative 10, which is 1 plus or minus 2 root 2. Now, obviously, minus 2 root 2 is going to give me a negative number, so I only have to care about 1 plus 2 root 2, which is 3.8 when I punch it into my calculator. So that is 3.8. How high is the bridge above the river? We already know that because it's the y-intercept, 35 meters.